Welcome to my channel, Chemistry Class. Good morning, everyone. Welcome back to Chemistry Class. My dear student, I hope you are all doing well. My dear student, today we are going to study another very important contribution to atomic theory, which is Niels Bohr atomic models. My dear student, Niels Bohr's atomic models are presented in 1913 after the discovery of Rutherford's models. Some questions remained unanswered, especially about the stability of the atom. But dear student, Niels Bohr came forward and provided answers to these problems by introducing his atomic model based on quantum theory. Now, my dear student, we study background. Rutherford model explain that atom has a central nucleus. Electrons revolve around the nucleus. No problem in Rutherford's model. Classical physics says moving electrons should lose energy and spiral into the nucleus, making the atom unstable. And the second one could not explain the line spectra of elements like hydrogens. Like hydrogens are. Now, my dear student, now Bohr's assumptions. The first one is electrons revolve around the nucleus in fixed circular orbits called energy levels or shells. And the second one is these energy levels are at fixed distance from the nucleus and are represented as K, L, M, N or by numbers 1, 2, 3, 4. And the third one is electrons in these orbits do not lose energy while moving in stationary orbits. And the fourth one is electrons can jump from one orbit to another by absorbing or releasing a fixed amount of energy known as a quantum. Now, my dear student, explanation of stability of atom. Electrons in a stable orbit do not emit energy. When an electron absorbs energy, it jumps to a higher orbit excited state. When it returns to its original orbit ground state, it releases the absorbed energy as light photons. My dear student, this explains the line spectra of hydrogens where only specific colors are emitted due to electrons jumping between fixed energy level. Now, my dear student, key features of Bohr's models. Electron revolve in fixed orbit shells. The second one, no radiation of energy occur in the same orbit. And the third one is energy is emitted or absorbed only when electrons jumps between orbits. And the fourth one is each orbit has a fixed energy level. And the fifth one is this model explained the stability of atom and the spectral lines of hydrogen atom successfully. Now, my dear student, limitations of Bohr's model. Though Bohr's model was successful for hydrogens, and hydrogens, like atoms, had some limitations. Could not explain spectra of multi-electrons atom, could not explain the behavior of atoms under strong magnetic or electric fields like Zeeman and Salk effects, failed to explain the fine structures and spectral lines. But student, these were later solved by quantum mechanical model of atom, which you will study in higher classes. So, students, Bohr atomic models was a major improved over Rutherford's model, as it explained the stability of atom, explained the line spectra of hydrogen's atom, introduced the concept of quantized energy levels. So, my dear student, this is all about today's lectures. I hope you are all understand. My dear student, if this lectures help you, then don't forget to like the video and subscribe to the channels and press the bell icons and share it with your friends. Also, comments your question or any doubt below. Take care and see you in the next class. Thank you for listening.